Yo, what is up? What is up? Welcome back to another. Oh, what the fuck dropped? Oh my gosh. I freaking. You know the thing that, like, where you plug all your cables into? Whatever that's called. That thing dropped on the ground. So it was on the table. Anyways, welcome back. It's been an entire year. Today, we're gonna start a series where we leak code until I get a job. Alright? That's the goal, because it's been pretty rough at these days, bro. The economy's doing bad. Filling all my applications to my computer science jobs. And to fix that, we're gonna start Leetcoding. For the uninitiated, alright? Leetcode is basically practice problems where you code like algorithms or problem solve that a lot of companies use on their interviews so that they can kind of gauge or proxy how good your actual skills are, right? So yeah, that's like basically the premise. And today's the first day. Let's jump in, bro. All right, 75 sort colors. Okay, that zoom is way too high. Let's see here. You are given an array of numbers with n objects colored red, white, and blue. Okay. Sort them in place. Sort them in place. Objects. Get an array of n objects colored red, white, and blue. Sort them in place so that objects of the same color are adjacent with colors in the order red, white, and blue. Sort them in place. Let me highlight this. Same color are adjacent. Alright. Whoa, my bad. Order red, white, and blue. Zero, 1, 2. We'll use integer 0, 1, 2 to represent color red, white, and blue respectively. You must solve this problem without sort. Without sort. Okay. Alright, let's run through this real quick. Red, white, and blue. So it's zeros together, ones together, and whites. And twos together. 0, 1, and twos together. So we're sorting an array in places, basically, right? That's the whole entire point. Alright. No sorts. Alright. Well, let's do a practice problem right now, or like look through how we can simply solve example 1 first. It's 2, 0, 2, 1, 1, 0, 0, 0, 1, 1, 2, 2. That makes sense. Okay. What can we do here to turn this into this? Okay. We can compare 2 with 0. Because 0 is smaller than 2, swap. No sorts allowed, okay. We can hash it. We can create a hash map, but that's not modifying in place, right? If we make a hash map, we go through it once, make a hash map, and then we just create if we make a hash map, loop through it once, we have the amount of iterations or the amount of zeros, ones, and twos, and then we can just overwrite the old array with the new input array. That's n squared, right? But I don't think this is the recommended solution for a problem. For context, I'm working through like a kind of like an outline of problems I should kind of solve in Leetcode. Outline or course, you can say. And the idea behind that is that there's certain patterns that are tested for this section of the outline, right? And currently we're on the 2-pointer section. So I know we're supposed to use like 2-pointers or 3-pointers of some sort here, I feel. So I think my solution works, the hash map one, but it's probably not the right one. Okay, let's say we go through, we find the amount of zeros first. We for loop through it twice, find the amount of zeros. Well, that's n cubed. Then if we just find the amount of occurrences per each value. Technically, we can just do n squared just by running 2 for loops. First time we calculate the occurrences of everything, and the second time we put it in. That's also not 2-pointers, but it works. It's just like a mini hash map. Makes sense, right? If 0, we insert it into, we increment one value. If not, increment the other value. That's the simplest solution I have. But 2-pointers, where can we put 2-pointers? A bubble sort of some sorts? That's technically 2-pointers. But that's not, okay, bubble sort is for, okay, so if 2 is greater, for loop, and then if greater, swap. How does bubble sort go again? Let me try to think here. Man, okay. I don't know, guys. This is low-key hard, bro. Okay. It's not that bad, but I just don't know what the most efficient solution here is. Okay, so we run a for loop first element. If the first element is bigger than the second element, we swap. Oh, while, maybe we do while first element is greater than, okay, so for loop. We have a for loop for the bubble sort. We have a for loop inside that. We have a while sort. While loop, while we're gonna have like a left pointer pointing to the first, pointing to I of the for loop, and then a right pointer pointing to I plus 1 if I, while I, nums I is greater than nums I plus 1, we swap, and then we increment I, and we keep doing that. Well, but then if there's a super large element, then we're kind of stopped in our tracks, right? I don't think that's how bubble sort works. If I can think back to it, is that how bubble sort worked? Right, because if it's just large elements, we suddenly encounter a large element, and preceded by small elements, the while loop ends, and then we go on to the next one. Do the same thing, do the same thing, do the same thing. But then again, we eventually reach a large one in the for loop, and we bubble that up, right, to the end. And then, but the values after the large for loop, let me kind of picture out what I mean. we kind of have like a 0, 1, 2, 0, 3, 2, 1, 120, and 0 and 0. Not pertaining to a particular like this problem, but get the idea. This is swapped correctly, right? So for loop 0, that's fine. 3, this is gonna swap with 2, and then 3, and then we go on to the next for loop. The 3 swaps with 1, and then we stop swapping, and then 2, and then we go here, 1. Yeah, and then we skip the 2 as well. This is not how the bubble sort works. I just don't remember. I'm trying to think. Now, let me do a mini one first. Just normal bubble sort algorithm. 3, 2, 1. Okay, so while I is, this is greater than that, while this 2 is greater than nums I plus 1 is greater than I, which with I being 0 right now, we swap, which means 2 and 3, and then greater right now, we swap again, which means 1 and 3. Essentially, then we've passed this one, and now we're on 1, and then greater than I plus 1, no, and then this is the end of the algorithm that I proposed for bubble sort, which doesn't make sense. This is not how bubble sort works. I vaguely remember another, like 2-pointers problem where there's some like override written. I might just go with the hash map here and look at the hint. No, I don't want to give up on the supposed 2-pointer solution. guess for... Man, I wish I remember my sorting arguments. 3, 2, 1. Okay, for loop. Start at 1. Start at 0. If it bubbles up, I'm assuming then we can do it. Like, I'm making up this algorithm on the spot. I'm not sure if it's even true, right? If we're assuming a swap has occurred, which means something like this has occurred, right? It would be like, if we just say if swap occurred, we don't iterate the I, so then it's back on 2. Swap occurred, so we don't iterate the I. Does that just work? Okay. Right, so that happens because we stop at 120 because 3 is not greater than 120, and then we do 2 because we're not iterating the I here. That becomes 1, 2, 1 and 2 swap. We don't iterate the I here because there's a swap. Okay, so now we walk through, and 1 is chill. And 2 is chill. Right? We have to rewalk, but that's ultimately alright, I think, because it's just 2n, right? It's never gonna be n squared here, I don't think, unless it's up perfectly. I think we're overthinking that. It's okay, we'll just keep going with this kind of line of thought. That's 1, 2, 3. We do iterate now because we're not doing any swaps. No swap on 1, no swap on 2, no swap on 3. So now we're at 3 and 120. Alright, so then we do 1, 2, 3, 120. We don't swap here. We do 120. That beats 120, right? But then how do we get the 1 back? I have no clue. So there's something wrong. Right, we fucked up. So this is not the bubble sort algorithm. How did it work? Man. I'm so lost. Just hash math it? I don't want to. That's so... We know there's something else here. What happens to this 1? I guess we can do reverse like backwards swap as well. We do a for loop, right? And then each element gets a swap if it's. You can swap both sides, I guess, bidirectionally. But that's just like infinite swaps. Right. No, not really. Okay, let's try to reuse this analogy. So you can swap both ways then, which means if 3 is, we don't do it on the first one. 2 and 3 swap. If 3 is greater than, if 3 is less than the one before, then yeah, we gotta swap, but it's not in this case. 3 is greater, so we don't swap. Or if 3 is greater than the one after, so we swap that. 120, there's a pause here, right? And then we don't change the iteration. 1, 2, 2 and 1 swap 3, 120 and 1. 1, 2, 3, 121. So now we're at, we finally start iterating 1, 2, and then 3. Yo, I'm low-key buns at this, bro. I can't lie. Okay. 1, 2, 3. We're at 3 now. Keeps iterating because there's no swaps that have occurred. Nothing fits the criteria. 120. Okay, 120. So this is swap of 1. Since no swap occurred, that's alright. I mean, since no, what do I say? Since a swap occurred, we're back at 1. Back at 1, not greater than 120. So we're not going to right side, no, but it's less than the one on the left side. So it's 1, 3, and then we keep going while this is the case. Less on the left side, 1, 2. That's on the left side, no. And then that is a sorted array in place. Swapped. What is the for loop and then another, okay, we for loop it with swap in the middle. Swap, swap, swap. We don't swap. We do a theoretical n amount of swaps. Max for each, so n squared, same as, I guess it's the same. I'm gonna venture to say it's the same as the hash map, but with a lower space complexity, because we're not creating, wait, not really, because hash map is also, no, hash map is O of n, this is O of 1. Right, because we're just swapping in place. And both are n squared. Okay, we can try this. I think this should work. Okay, so for loop. Nums. I'm just gonna write out pseudocode first. Don't. Nums I greater than +1 swap. Oh, we have a while loop here probably. While. This should be nums I minus 1 and I plus 1. We're just going to do I minus 1 here and just for simplicity. Well, we can't even do this if we're At a zero index, I suppose. Oh, shoot, my cable fell again. So we start at 1, first index. Yeah. Something like this, I feel. That'd be good. While loop kind of breaks if you're on the edge, like the very edge here, so. For our length. So if we're at 0, can look back. Is that ultimately fine or no? I guess we can just not check that condition if we're at 0. Well, that's kind of stupid question. I mean, we can just have it if that runs here. I don't know if this OR statement kind of counts here. Okay, we can try catch the OR. That's stupid. No. Those have been a while, but I mean, technically, if a swap occurs, you never have to venture as far as the. Yeah, you never have to venture as far as the edges, unless it's the base for loop in itself. Right. Yo, what the fuck am I saying? Okay. Wait, we're just gonna try this and see what happens. See, I have something, I don't know if this is, if we're on the edge here, we're just cooked, no? Because we can't check for nums I -1. Like, and I think if we're doing all these nested statements, it's way too complex, so there's something wrong in the first place. Like, do I want an if statement for the first one and the last one? That's stupid, right? I mean, that's not as stupid, no. But I feel like there's so much like extra lines that is not needed for the most optimal solution, I feel. Like, there must be something I'm missing here in terms of like how swapping is kind of occurring. I mean, if we start at 1, let's say theoretically we start at 1 here for 2. 3 is greater than 2. So 2 and 3 is immediately going to swap. And the index here now should still be on 3. Should I change? What the fuck? Suddenly I heard the sound of my fan. Okay. Yo, fuck my dude, my chunk, bro. My brain's cooked, bro. I can't do this, bro. Maybe I'll just hash map it, bro. Am I overcomplicating this, bro? Maybe I am. Okay, if I start at 0, I mean, I guess I'll just add a while condition. I don't know. I guess if nums are okay, we'll come back for the edge case. Later, let's just write out general algorithm, I'm assuming. Whatever. I'll separate the variables here. Like this, and then less than count, less than that. Okay. You must check the index here, right? This is like, we're gonna switch the index here after you do that. Swap forward. This will mean count plus or equal 1. Oh man, I dropped my pen. I'll have to. While I was swinging it. Great. Shit. I'm gonna get it. How long has it been? Let me check. 34 minutes. Okay, no, I can think about this for a little longer. Is that medium? This should be easy. No, I'm low key. I feel like this problem is not hard. Oh man. I'm just like I'm just being a chud, bro. I don't know, bro. This is just a simple sorting algorithm I'm trying to refigure out. I feel I'm trying to like optimize. I don't know how because I forgot. Okay. Okay, so we're in this situation where we keep swapping. And there's going to be a situation where We can do something stupid here. There's just a lot of... I don't know, I don't think this is it, but whatever. This is so stupid. I don't think this works. Oh man. What if I just go half? Okay. Oh, my bad. Oh. My bad. That's really badly written. Yeah, this doesn't work because, fuck. Oh, man. Because this loops it until, oh, man. Well, okay. I can do this. Where's count? Okay. Wow. Fuck. Does this work?
一说话就埋怨，跟着合作肯定是。你看，你喜欢这个枕头还是喜欢这个枕头？
我忙呢，可以等一会儿吗？嗯，咋？
这个枕头好还是这个？
我现在忙了，待会儿行吗？做题呢。One pass algorithm using only constant extra space. Oh. Oh. Okay. Oh my gosh, okay. Oh my god, okay, well, we'll submit. No, we'll copy this in, okay. I think I have something. I just suddenly remember something. Oh my gosh. Paste. Why is it not? Is it working? Hello? feel like, why? Yo, what is happening? Why can I copy and paste this? Yeah, that's, yo. Okay. Control C, Control A, C, Control V. Control V, okay. Okay. Alright. I've suddenly had an epiphany, I think. Give me one sec. Okay, it's something about placing them in this extra new array. I have some vague memory of doing like a similar problem. It's like using pointers and placing them into this new array. No. No, I don't remember anymore. I'm just gonna hash map it. Think this works? I don't even know. I don't even know the dictionary like keywords in that Python though, because I'm just learning Python. Okay, so then also because it's just meaning a skill issue. If I just do this? I think so. Okay, and now I do for okay. I don't know the keyword for iterating through a dictionary. I don't know if you can iterate through an order, I guess, because from ascending and descending keys of 0, 1s, and 2s. I'm gonna search this up. Iterate. Dictionary Python. Oh, then I have to sort. Okay, nah, that's stupid. Okay, well, I gotta do something like num1, num0, 1, num2. Go 0, equals 0, equals 0. So stupid. 0. Mm. And then we just do can this just straight up so stupid. I think this works though, at least. I don't know. You know, one pass though. Wait, can we just do two sum on this? Some shit. I don't know the algorithm well in my head though. It's not like ingrained. Oh man. Well, I guess we got better over time. But this Loki sucks, bro. I'm kind of ass. Question mark? Oh wait, shoot. Count. What? Can I do that? Just do this then? Oh. Oh shoot, what are we doing here? Out of range. That doesn't make sense. What? Two zero 2 1 1 0 0. Okay, so 1 2. So it's 1 2 for each one. Okay. 1 2. So 2 num zeros. Okay, let's print nums for each one, but I don't know why this doesn't work. This is so simple. It's like the most simplest way to do it, I think. Kind of sucks and it's really ugly, but it should work, no? I don't know what's not working here. It's not working at all. Oh. Fuck. That looks good. Okay. Okay. Zero zero one two. Open disk. Okay. 2 2. Num2 still not 0. Yo, what? Okay. There's 2 zeros here. How do we get 3 zeros? Oh. Yeah, 0 0 2 0 2 1 1 0. There's so that becomes 2 becomes 1 2. 0 becomes 1 2. 1 becomes 1 2. Okay, so now we start. Counting is go to 0. Now you go to 0. Count increments by 1. Decrements by 1. We print once, and it does that twice, so then we have a 0 0 case. Why is this 0 at the start? I'm so confused. That doesn't even make sense why this is a 0 here. How does that even happen? What? Yo, I suck at this. Oh my gosh. How does that even happen? Did I do something wrong? Nums. Yo, what? Hello? Okay, 1 and 1. What if it's not a 2? That's not even the case. Oh, wait. There we go, okay. Found it. There we go. No, not it? Okay, cool. Sorry, correct? 4? Oh. Yeah, that should work better, I guess. Oops. So if it's not that, yeah, that was a stupid logic mistake. Okay. There we go. I could have just printed nums. Oh no, I could not have. Wait, what? The runtime beats 100%? Hello? I should have just done this at the start. What? I guess this is 2 add, huh? Okay, but this is kind of stupid. This is not 2-pointers. Wait, is this 2N? Yeah, once. And just twice. Okay, yeah. I guess I overthought the question. Should have just done this at the start. Unless there's a Sunjin, let's guess how Sunjin did it. Oh, there's a swap. Okay. Ah. Okay, let's try to figure out the right solution. Okay. Kind of want to just watch Nico's video, I can't lie. Not sure if I can watch that on the... I don't know if I can watch Nico's video on my own video. That's kind of weird. Okay. Oh, ones. Okay. Wow, that's so... I feel a little unintuitive, I feel. Well, I mean, my time complexity is technically the same. So... I do kind of want to understand this. Like, I think this is... I'm trying to understand, like, how 2-pointers work, I guess, better. I'll look back at this problem, I guess. I don't know. I think that's all for today, I feel. I'm gonna try to practice this problem again later, using the correct solution, now that I've, like, kind of understood what's happening here. I'll read through it a little more afterwards. But, hey, good first day. I think I overcomplicated it with the hash, with, like, trying to... I was trying to, like, swap it with the 2-pointers method, so it's whatever. But, yeah, if it works, it works. Alright. I will catch you guys later then. Peace.